That's okay. All right. Like I said, I have a massive hangover, or not hangover today, listen to me. I have a massive headache today. The hangover was yesterday. Phil. All right, let me just pre-state, we are not going to try to become masters of motor control after this 1 week, okay? We have a whole semester dedicated to motor control. This is just to get your feet wet, okay?
Objectives. Determine branch circuit and feeder ratings and conductor sizes for motors. Determine maximum rating of branch circuit and feeder short circuit and ground fault protection for motors. Determine appropriate overcurrent protection for motors. Summarize the meaning of the terms type 1 and type 2 protection.
All right, so we probably won't be getting into any of this. I'm just going to be covering what I want you guys to know, and I'm going to make the questions to reflect that. I do not want you guys to become masters of motor control. I don't even want you to attempt it for this 1 week. We have a whole semester coming up. I want you to know some basic introductory things, so when we get into motor control next semester, you're a little bit more well educated as to what we're going to be getting into.
Explain how to properly locate the disconnecting means appropriately for controllers and motors. Explain, interpret the word appliance. Choose an appropriate method for installing electrical circuits to appliances.
And take this last one again.
Explain how to properly locate the disconnecting means for appliances. Identify appropriate grounding for appliances.
All right, when they say appliances, what do you think they mean by that?
Your dishwasher.
We're talking, like, in this sense, we're talking larger appliances. So like a dishwasher, yeah, that could be an appliance, but like something that's gonna be like 240 and up, right? Like in commercial mixtures, like stuff that we'll find in the commercial kitchen, motors, both 2-pole and 3-phase. That's what I mean by appliances.
NEC Article 422 sets forth the installation requirement for appliances. NEC Article 424 applies to fixed electric space heating equipment. NEC Article 430 applies to motors, including those part of motor operated appliances. And NEC Article 440 addresses air conditioning and refrigeration equipment.
All right, so there's a lot of articles that set forth for specific areas. We're talking about hooking up appliances. What are two ways that we can hook up an appliance? What are the only two ways that are possible?
Like electrical, like energizing?
Yeah, like how are they hooked up to power? There's only two ways an appliance can be hooked up.
Directly to the branch circuit and plugins?
Yeah, plug-in or hardwire, as we would call it, hardwire. Good.
The basics of motor circuit. Motor failures happen for many reasons: abuse, lack of oil, bad bearings, etc. See Electrical Apparatus Service Association regarding motors and common failures. Disconnecting means. The code requires that all motors be provided with means to disconnect motor from its electrical supply. The motor circuit switch must be horsepower rated.
All right, so yeah, motor failures are usually not because of the electrician. It's usually not because of the overload. It's usually not because of electrical current charges, weird things. It's always abuse, lack of oil, bad bearings. You just getting the fucking tar beaten out of that motor. As you'll find out in motor control, there is a way that we balance these with lasers. Yeah, because it's all shaft alignment. So when we were working at not Lockheed Martin, when we were at General Dynamics downtown, the big bomb factory, everybody's aware. I was a plumber for a year before this, and I worked with Scott's Plumbing. They're the best plumbers in the area, so we did some crazy shit. They had one room with four 200 horsepower motors. You can stand on these things and work on them. I think they were all 600 volt 3-phase. They're like a step above 480. And we had pumps hooked up to each one of these, and they would just pump coolant around a big forge that would make mortar shells. All right. We had to replace all the pumps because they were all shot. We had to replace all the piping going to the pumps because they were detonated. And when it came time for us to balance the pumps, we were like, all right, we'll get these close. We're tradesmen. We know how to measure. We got this. So we got it all nice and close, pull out our levels. We're like, all right, when the balancing guy comes, he's not gonna have anything to do. He's just gonna come here, slap it on, call it a day. How fucking wrong we were. This guy balances it to 1/1000th of an inch. He pulls out with cards that are no thinner than a piece of paper, sliding them onto the motor, trying to get that perfect shaft alignment. Because the alignment, like the tolerance for a lot of big motors, is only like 1 or 2 or 3 thousandths of an inch. So if something gets bumped, something gets jostled or abused, that shaft alignment is going to come right off. And then what's it going to destroy? It's not going to destroy your motor right off the top of the head. It's going to destroy the bearing in it, which will then destroy the motor. Does everybody know what a bearing is? What's a bearing, Phil? Describe a bearing to me.
There's like 2 rings, and then between each are like metal balls.
Yeah, otherwise known usually as a ball bearing. But yeah, they just reduce the friction between 2 points. Usually a bearing is round. They can be flat. Also, we have ways of testing an entire motor just by sound and frequency. You can put a little block on top of the motor as it's running, and it can tell you how the health of the bearing, the health of the shaft alignment, the health of the motor itself, just by listening to it. So there's a lot of ways we can test that, but most motors shit the bed due to abuse, 9 times out of 10. The other 10% is heat. Heat destroys motors. As we'll find out, overloads are going to be becoming a thing. Disconnecting means there's a whole bunch of codes in place to show where the disconnect can be in correlation with that motor. The disconnect has to be usually within eyesight of that motor. Usually no more than 12 feet away, if I'm not mistaken. Who's up? Back there?
Disconnecting means any scene rule number 1 must be in sight of the controller. Any scene rule number 2 must be in sight of the motor location and driven machinery. Do start, stop, and lockout stop buttons qualify as disconnecting means. Not considered the required disconnecting means.
So what do they mean by disconnect? Obviously like a big ass disconnecting thing, little lever action, nice firm, turns that motor off, everybody feels nice and safe. What they mean with the lockout tagout is, yes, would the lockout tagout prevent the circuit from being energized, from being turned on? Yes, but only usually the control side. You gotta make sure that that disconnect, what's supplying that motor with 3-phase power, is in fact killed. And when we're talking about here, let's back up one slide. The motor circuit switch must be in horsepower rated. We don't go by amps anymore when we're dealing with motor control. It goes by horsepower rating, okay? Once again, I am not going to get into all the nitty gritties. There's too much here to talk about. Just so you know some blanket information so you know what you're looking for when you get into motor control next semester. Everybody know what a lockout tagout is? Anybody ever hear that before? Describe to me a lockout tagout. Do I go in the toolbox and get my lockout tagout briefcase and walk in there? And, no? What's a lockout tagout? Nicole, help them out.
So it's when you actually lock the device so it can't be turned back on or energized, and then you also put a tag on it, or I'm pretty sure a lock also works.
It'd be vice versa. You throw the tag on it with your name,
Oh, okay.
and then that tag usually has 6 ports that you can put a lock onto.
Yeah.
So it'd be like a team. So if you have a team of electricians working on something, you throw your tag on. This is a Joyce tag, or whoever I'm working for today. And everybody who's working on that circuit throws their own lock in there. You can have 6 locks, 6 guys working on that circuit, but that circuit can't turn on until everybody comes and takes their lock off. So that's a lockout tagout. Should you ever cut a lock?
No.
A lockout tagout. But what if I'm your boss? Come on, man. I know that's fine. Go and cut that lock off really quick.
I talk to the other electricians and stuff like that.
No, you just never listen to me. You never listen to me. If anybody tells you to cut a lock ever, it's no. The answer is no. You go and talk to the person whose name is on the lock and have them. You don't even say, can I unlock it? You have them come and unlock it, because now all that trouble is on their shoulders. If they just gave you the key, yeah, unlock it, you're still liable. You know what I mean? So have the person whose name is on that lock only unlock that lock. I can't stress how important that is. Okay. Let's continue.
Air conditioning and refrigerating equipment disconnect. NEC 440.14 lists a number of requirements. Exhaust fan. NEC 430.111 permits a single pole snap toggle switch to serve as both controller and required disconnecting means.
Yeah, but when they're saying exhaust fan, they're thinking like, you know, not something in your bathroom. They're talking huge, talking like a 4-foot blade. They do make 3 pole switches. Any idea how that's possible? What the hell would a 3-pole switch look like, you think? What does a single pole switch look like? I'm sure you can describe that to me.
Just a basic switch just goes up one way or,
If we're talking about the terminals.
oh, I just had 2 screws on each, or one screw up, one screw, or just had 2 screws on it.
We're not going to concern ourselves with ground, but there's 1 in, 1 out, right?
Yeah.
On a single pole switch. 2-pole switch is 2 in, 2 out. The same toggle kills both sides. Well, there is a 3-pole switch, 3 in, 3 out. That's what you use especially if the exhaust fan is 3-phase, because once again, 3-phase motors do not require a capacitor to start. So it's just the power itself. And if you were to switch legs 1 and 3, that motor would spin in reverse if the motor is rated to go in reverse. Every 3-phase motor can reverse, but only certain ones are rated to actually go in reverse. So if you flip lines 1 and 3, it will spin your wrong direction, which is another basic concept of motor control.
Basics of motor circuits. Motor branch circuit conductors not smaller than 125% of full load current rating of motor as found in NEC 430.22. Color coding for motor branch circuit conductors can be just about any color with certain exceptions. The choice is pretty much up to the electrician.
Yeah, but once again, if you can keep those colors the proper, it's not going to hurt anything. Not smaller than 125%. When you're looking at a 3-phase motor, just think 125% off the top of your head. Just envision that can be continuous load and upsize your wire accordingly. You know, I know some pass the exception, but like I keep on saying, I try to do above code minimum. So if 25% might be a thing on some, it might not be a thing on others, I'm just going to make it a thing on all. All right, CYA, cover your ass. But yeah, color coding. When we're in lab, like all the control work, because there's the high side and the low side. There's the main power side, and then there's the control side, which you guys in PLC are really concentrating on that control side, right? See what all your relays can do. Your starts and stops are all in a particular order. That's the easy side. Usually that's all in one color. I usually do red or black. The 3-phase side of it though, there's no harm in having your black, red, and blue, or if it's 480, your brown, orange, and yellow. It's just gonna make things a little easier to see, and you can see what legs are what.
Motor overload protection. Proper protection protects motor branch circuit conductors from overheating. Overload relays, most common form of motor overload protection. Relay types include thermal. I'm not sure how to say that.
My head hurts too much to even try to
Okay.
think about
And
that today.
fixed and interchangeable bimetallic and electronic solid state. Some overload relays are manual reset, others are automatic reset.
All right, anybody ever hear this phrase before? Overload relay, overload. Anybody in PLC yet? Have you been talking about that? I doubt that's even a thing in PLC. Okay. What are your thoughts there, young man back there? What do you think an overload is?
So too much draw
Too much drought does what?
causes heat and
Boy, you're on the right track. Little do you know, you're on the perfect track. Ah, he was close. All right, so let me fill you in. So an overload is kind of like a circuit breaker. but it doesn't give two right bananas about how much current is going through it. Doesn't care. 100 amps, 200 amps, 300 amps, gives no hoots. The only thing that overload cares about is heat. That's it. It's the only thing. You know, like the motor, like when you start a vacuum cleaner, right, in your house, what happens to the lights? Especially if you're in an old Scranton house, what happens?
They flicker.
They dim a little bit, right? Because that initial startup current is really high, and then it stabilizes back down to its normal 12.5 amps or whatever. Same thing with a three-phase motor. Can you imagine how much power and torque and current goes into starting like a 100, 200, 300 yard conveyor belt? Especially if just one motor's running it. And then it starts going. Then it goes back down to its, you know, normal amperage level. It might spike up to 50 amps and then go back down to 30. All right. So an overload has to allow that initial startup. It has to allow that high current to go through. It's more of a time thing. If it senses too much heat over too long of a time, it'll pop, killing power to the motor. Now, when they say some are manual reset and others are automatic, the manuals, obviously, you have to go and hit the reset button and then it'll turn right back on. The automatic resets, they wait until they cool, they go back into their normal position, and then they'll fire again. Manuals are good if like it's gonna be in like a factory, like somebody's gonna be around that machinery. You know, you turning on that machinery that machinery turning back on randomly might hurt somebody. That's when you're gonna want a manual. However, if you're in like a pumping station for like a sewer and that motor gets too hot, I would much rather let that motor cool off a little bit and turn back on versus somebody climbing down to that sewer every time and hitting a manual reset. Do you see how like different objects can be used in different situations? Good. Most of these are bimetal strips. I'm not sure if that's what they mean by that, bimetallic. What happens with the bimetal strip? Where do you see a bimetal strip? I'm really beating you up today. I want you to get one answer right. Where do you ever see a bimetal strip? What does a bimetal strip even mean? Phil? Bimetal strip? Ever hear that before? Sir? Bimetal strip?
Combination of metal.
I'd say you're good at guessing. Has anybody ever seen a thermostat hanging outside their house? Like not a thermostat, rather a thermometer, right? With that metal coil in there. That's a bimetal strip. And as it gets hotter, what happens to that strip? It expands. It turns your thermostat to a higher temperature. As it gets colder, it contracts, turns that back down to a lower position because it's two different pieces of metal joined. And they are dissimilar metals. So if two metals are different, they're going to heat up, expand, and contract at different temperatures. Am I right? So when it starts heating up, it's going to start bending. And at a certain point, a bimetal strip in a overload will bend and break contact. It'll break contact until it cools down, turning that motor back on. So once again, it's kind of like a circuit breaker. It's a circuit breaker of the motor, but it does not care about amperage or voltage. It only cares about heat because that's what's most detrimental to an electric motor. You know, you heat the piss out of a magnet, what's going to happen to it? It's no longer going to be magnetized. Well, same thing with our motor. If we heat the piss out of our motor, that motor is going to be useless. So it's the exact same theory. Who's that? Start that from?
Basics of insulation. Motors have different classes of insulation. Manufacturers select motors based on their use. Service factor. Sizing motor overload protection depends upon the service factor of motor. The service factor is found on the motor nameplate. Load obtained by multiplying rated horsepower by service factor.
Yeah, so there's always going to be a nameplate on your motor. And based on the motor, it might give you just basic information or it might give you a plethora of information. Usually the nicer the motors have more information. And more information for us is better because it leaves us less guesswork and less calculations to pull. They're usually going to tell you if it's rated for reverse, if it's rated for forward, if it's rated for like slow speeds or just full speed. They'll give its insulation. It'll say what voltages it's rated for. It'll say its wiring pattern for those voltages. It'll give you pretty much everything on it. I'm not concerned with you guys figuring out the load factor or the service factors yet. We have, once again, we have a whole semester to talk about that. This is just surface level information we're trying to go for in this one.
How does current flow in windings of a motor? Single-phase motors require overload device in one conductor. Current that enters motor on one conductor comes on one motor, or enters motor on one conductor comes out of motor on the other conductor. When overcurrent device opens, flow of current to motor is totally cut off.
We don't even care about single phase motors. What I mean by single phase is, you know, like a vacuum cleaner motor, any stupid, foolish thing. You'll never see a single phase motor in a commercial application. Why? It's just one hot and one neutral, right? And if it's running a really big motor, it's going to cause a lot of energy to use, right? We don't like paying for that, do we? So let's say like you have a 1 horsepower motor and it's single phase. You know, it might be drawing 30 amps. Whereas if you switch it to a 3-phase, it might be pulling 7. What would you rather pay? You know what I mean? Is the initial cost of the 3-phase motor a lot more? Absolutely. But its longevity and its cost of running is going to far beat the shit out of that single phase motor. So in most commercial industrial applications, you don't see single phase motors ever. That's for residentials or extremely light commercial applications. You always want to either make it a 2-pole or a 3-pole just to get down on the efficiency. Or just to get better in the efficiency.
Single phasing. Single phasing means one phase is open somewhere. Can be caused by such items as a down power line, utility company's primary transformer fuse, cutout being open, open connection, bad termination, open splice, broken conductor, burned open contacts in the motor controller, bad contacts in a switch or circuit breaker, an open winding in the supply transformer, or a misalignment.
Whew, boy, that can be caused by a lot of shit, huh? Good thing we're electricians, good thing we can do some troubleshooting, good thing we can figure all this out. What do you think I mean by single phasing? I don't call it single phasing. If I experience it in the field, I'll call it something else, but they'll give you up an answer. So what do you think single phasing is? Means one phase is open somewhere. That's implying what?
There's like a break in the line.
Well, it's implying, number one, that there's more than one phase, right? The motor is still running, believe it or not. If it's a 3-phase motor and you drop one phase, it's still running. But what happened to that? So now you have 3 legs of power coming to feed a motor, right? You took one away. What do you think is going to happen to the other 2 lines that are still running? Do you think their amperage is going to be the same, go down, or skyrocket?
Skyrocket.
Skyrocket, right? There's a chance if your overload doesn't catch it fast enough, it can blow that motor sky high. But when they call it single phase in here, I call it losing a leg. Does that make a little bit more sense? We lost a leg at the motor. Oh fuck, we lost a leg. Now, normally they don't even make the same sound anymore. Normally they spin. When we have 3-phase motors going, you'll actually be shocked to find out how quiet they actually are. They just hum. When you lose a leg, they can still hum, or they can just sound horrible. They can just sound like a terrible grinding, garbled noise, but they will still run, unfortunately. So just know that if you lose a leg, it's best to kill that immediately if the overload didn't catch it yet. And you might want to check your motor because it could have been damaged heavily, especially if it was trying to move something very heavy and it just only had 2 legs. You know, you can burn up conductors, you can do a lot of bad things. But all that can be caused by this. And to further add to trouble, I got a call from Mr. Visbisky down in HVAC. Hey, Mr. McKenna, I got a compressor that's spinning backwards now. And it's the only 3-phase compressor in the shop. I'm like, huh. He's like, none of my students touched the wire. He's like, and now it's spinning backwards. He's like, how the fuck is this even possible? I'm like, oh wait, PPL was here over the weekend. What do you think PPL did? Accidentally switched lines 1 and 3. So what's going to happen to anything that's connected on that system in the building? It's now going to spin backwards. Crazy, huh? So just make sure, you know, like it's, all this can cause it, but even the utility company could cause trouble. So just know what your phases are. It further helps to keep them color coded so you know if there's issues. But single phasing can be caused by pretty much anything. Normally it's just wear and tear in the lines. We said before in grounding and bonding that anything that's in conduit is open to damage, right? Well, it's all these issues. Are there any questions as to what we hit so far? Strange things happen. Wait, is it you? You just read? You go ahead.
Strange things happen. Unexpected things can happen.
So strange things happen and unexpected things happen. Just so we know, okay?
If a large, lightly loaded three-phase motor is running at the time of single phasing, and other smaller motors connected to the system are running, the large motor acts as a generator and will feed back into the system on open phase.
Interesting.
Smaller motors not fully loaded on the system might start or continue to run, leading to motor burnout.
Yeah, so like a three-phase motor is actually nothing more than a generator, believe it or not. If you were out in the sticks and you were experiencing trouble, if you were to who watched Breaking Bad? You know, the same thing with the RV, right? They couldn't get the RV started, so they started spinning. Well, I don't know, whatever it was, like air compressor pump or something. But if you were to spin a three-phase motor at its desired speed, it would pump out that voltage that goes into it because it's nothing more than a generator. It's magnetic. It creates a magnetic field, creates energy. That's exactly what a generator does, but just with a lot more insulation. The generator is designed to do that. This will do it as like a side effect. But it is possible. Like if you had, even if you had a disconnect, let's go back to the conveyor belt issue. This is a common thing. You have a conveyor belt, right? It's hundreds of yards long. Is there just one motor moving it? Probably not. There's probably like 7, 8, 20, who knows? But if one disconnect is off or if one shits the bed, there's a chance that if everything is still moving that along, that motor that's no longer running or hooked up to power can still be creating power. People get fried just accidentally touching the lines. They think this motor is disconnected. I'm just pulling it off the system. It's just held on by sprockets. Oh yeah, I can take this motor off while the rest of this running. It doesn't need this motor. It's got 30 other ones. You can still get annihilated by touching those lines. If that shaft is spinning, it's going to create electricity. So just please watch out for that. It doesn't happen super often, but you should be aware of it. All right. Just like if you go down to the PLC lab, the 3D printers there. If you were to move, now they're all DC because they're sensitive electronics down there. If you were to move that pad back and forth, you would be spinning that motor in it, and you'll find out that if you move it back and forth, that screen will turn on because it's creating power. And conveniently, it's just enough power to turn that screen on. Now, is it good to be doing that? No, I was monkeying around one day. But I just wanted to see, can this be possible? And sure shit, it is. So, yeah, strange things can happen with motor control. That's why I like it so much. It's one of my favorite labs to teach. I put so much power in your hands, it's incredible. Jeep man, you're up.
Basics of motor circuits. Unbalanced voltage causes unbalanced currents in motors stator windings. NEMA recommends that it not exceed 1%,
Plus or minus 1%.
plus or minus 1%.
Yeah.
Voltage variation. Motors are affected when run at other than their nameplate rated voltage. Possible causes of unbalanced voltage. Large single-phase loads, open connections, unequal impedance, capacitor banks, unequal or open circuits.
Yeah, what they mean by that, and that's normally the biggest cause is large single phase loads. Like, that's why you really want to bounce out a panel box. You know what I mean? Like when I keep on saying, especially the residential ones, put your biggest shit on top. How many times have you heard me say that? Like your range, your dryer, throw the biggest shit on top. Really spread it out, make it even. When people do three-phase panel boxes, they get confused, or it's rookies. Shit, I only bought black wire. Fuck. oh, well, I have to run a bunch of 20 amp circuits. I'll just run all black and I'll just put those breakers in the black terminal, which is fine, it's code. But what happens if you have 20 breakers on there, it's all black conductor coming off, and then if you have one 3-phase breaker feeding a 3-phase motor? Do you think all legs are going to be even now? No, there's a huge draw on only one, and the other two are basically untouched. That's going to cause the most unbalance. Or in like the middle of summer when the heat is going, or when air conditioners run like crazy. When we go to a house, it's not uncommon to see like 235 instead of 240. Similar things like that can happen. The weather can play a factor, but 9 times out of 10, it's large single phase load that are causing all that issue. Open connections, unequal impedance. Another thing you want to be sure of is to keep all your conductors at the exact same length. If one is a foot longer, it will cause trouble. So with feeders feeding a panel box, they must be the same length. And for motor controls, it's not going to hurt if they're the same length.
Unbalanced voltage. Calculating unbalanced voltage. See text page 172. Dual element time delay fuses are designed to withstand motor starting inrush currents and will not open needlessly.
All right, so these are kind of these time delay fuses. I mean, I'm not talking about them in respects to unbalanced voltage, but that's another type of overload. You can have overloads that are just fuses, and they're set to pop with an X amount of delay. And it goes by before, like if you were trying to, let's say like your overload, your fuse was ready to carry 20 amps, and you were pushing like 20.5. Just a touch over. It's going to let that go for say 300-400 seconds before that pops. Whereas if you're trying to run 30 amps for that, it would pop after 2 or 3 seconds. It's an inverse type of time. That's what all of these dual elements, the time delays, your overload relays, they all have like an inverse kind of effect. If you push just slightly more, it'll let that go for a couple seconds because motors have that initial startup current. So it's going to come up high, and then it's going to stabilize. It gives that overload time for it to heat up and cool down while that motor is still running, because it has to allow that little bit of variance. Same thing with these time delay fuses. They allow a little bit to go by, but if you were to put a lot of amperage through it, they would pop pretty much immediately. So, any questions with dual element fuses or time delay fuses or overloads or anything?
Motor branch circuit, short circuit, and ground fault protection. Basics of typical motor installations. Conductors, controllers, and motor must be provided with branch circuit, short circuit, ground fault over current protection. Short circuit and ground fault over current protection must have sufficient time delay to permit motor to be started. NEC 430 and Table 430 provide maximum percentages permitted for fuses, circuit breakers for different types of motors.
Yeah, so must have sufficient time delay to permit motor to be started. What I keep on beating on is that when the motor starts, it's going to have, the startup current is going to be very high, and it's going to stabilize. You still need like overcurrent protection, like as far as your breakers are concerned. Your breaker could be set at 100 amps, whereas your overload for that same circuit could be set at like 68.8. You know what I mean? Your circuit breaker is always going to be well over what that overload is. That overload is going to be dialed in precisely. That circuit breaker is usually going to be added on for that 125%, all that jazz. So your circuit breaker is always going to be higher, amperage-wise, than your overload. Every time, all the time, without exception.
When ampere rating or setting does not correspond to standard ampere ratings, round up to the next higher standard rating. If the motor will not start with this rating, size of the branch circuit, fuse or breaker even larger. Check manufacturer's overload relay table for maximum size or type of overcurrent device.
Yeah, like I said, this motor could be rated for 5 horsepower, but it's just turning something that has like a lot of friction or something, like a conveyor belt that hasn't been greased properly or anything. That startup voltage by itself, or the startup amperage by itself, is going to be crazy. You add in more friction, you add in a longer belt, you add in anything, that amperage is going to increase that much more. So you need to have your system sized to be able to take that high initial current so it can stabilize back down to a lower number.
Starting current lock rotor current is usually greater than normal full load current. Starting current of a motor is based upon the type of motor and code letter found on the motor's nameplate. Higher the code letter, higher the starting current. Motor design designations. The speed, the torque, and the slip of the motor are taken into consideration.
So now what they're getting at here is, now there's some motors that are so freaking huge, like the 200 horsepower motors that I was talking about at General Dynamics. You couldn't just start those and they would turn on. They'd rip themselves apart. So there's like sets, like for the first 2 seconds it's receiving 20% voltage. For the next 2 seconds it's receiving 50. It'll slowly get that power up to like a full bore. Just like a conveyor belt, you know what I mean? If you turned on a massive motor and just turn it on, sometimes they're so powerful it would just shred everything. So you have to give it short jabs of lower voltage to get it up to a speed, like a VFD, like slowly increasing the power until it gets to full speed, and then it just runs. So that's what they're getting at here. But once again, I'm just touching the surface of what there actually is. And like I keep on saying, like that's the start current. It's always going to be high on any motor, and as the speed increases and everything starts moving, the power starts tapering off to its normal levels. Yeah.
Yeah, I'll go again. NEC table 430.7b lists code letters for electric motors. Motor design designations. NEC 430.52 in tables 430.52 and 430.251b reference design types of motors. Types refer to NEMA designation for alternating current polyphase induction electric motors.
Type 1 and Type 2 coordination. Type 1 short circuit protection. Contactor and starter shall not cause danger for persons working on or near the equipment. Type 2 short circuit protection. Contactor and starter shall not cause danger for persons working on or near the equipment, and contactor or starter shall be suitable for further use.
So you can just tell just by looking at it, it's just quality of build, right? Type 1 isn't going to be anywhere near as strong and reliable as Type 2. Type 2 can take a couple shots. You normally see Type 2 in like an explosion-proof kind of environment. Type 1 will just be like a standard commercial starter. Doesn't have to protect anything if it shits the bed. Okay, order a new one. It's not going to be the worst thing if this thing doesn't start right now. Type 2 might be that we need this motor to fucking run, no matter what. Like a sewer transfer pump. Like nobody wants to fill all of City of Scranton with shit. You know what I mean? Let's make sure that we can turn this motor on so we can pump this out. I use a lot of shit references because my dad works for the sewer authority, so that's always somewhere in the back of my mind.
Equipment installation. Industrial control panels used in both industrial and commercial applications might include motor controllers, overload relays, fuse disconnect, switches, etc. Must conform to NEC Article 409. Controller enclosures types see NEC 110.28 and Table C in appendix of this book.
So when they like industrial control panels, if you walk into the lab over there and you turn to the left, you see all the motors that are on the table there. Well, those control boxes that are on the wall, that's what they're talking about. It's a self-contained unit, usually made of steel. And it's going to house all that. It's going to house the motor starter, the overloads, the fuse disconnects, switches, any other sensors that might be in there. It's just going to be its home. And normally they can take a beating, you know what I mean? And two, if there's ever a short circuit problem, if there's ever a three-phase, like leg-to-leg issue causing an arc flash and arc blast, you would rather that be nice, burly, and self-contained, right? If that blows up, you don't want that lid flying open and spewing all that molten copper at you, do you? No, so they're usually rated to kind of carry that kind of condition, and they're usually isolated or self-contained. So if one were to blow, it's not going to cause a chain reaction of everything blowing around it. You just read? Did you just read? Yeah, you're right.
Equipment and lighting on a branch circuit. NEC 210.223A permits on a 15 and 20 ampere branch circuits. Supply of lighting and equipment provided, hardwired equipment, does not exceed 50% of the circuit rating. Combination load on an individual branch circuit. When a cord and plug connected appliance is supplied by an individual branch circuit, load is limited to 80% of circuit rating.
Yeah, I'm not really sure what they're trying to get at here, but this is a gold standard of anything. Anything you plug in should never encroach 80% of what a circuit's rated for, ever. You know what I mean? Does anybody have any questions about that? I mean, that's like first grade from residential wiring.
Supplying a specified load. Bake oven installed in bakery is electrically heated commercial type oven. A smart nameplate indicating load of 16,000 volt amperes at 3-phase, 208 volt. 6-gauge conductor having an ampacity of 65 amperes would qualify. NEC 110.14C1. Disconnect means without overcurrent protection is installed at the appliance.
Take this slide.
Conductors supplying several motors. NEC 430.24 requires that conductors supplying several motors shall have an ampacity not less than the sum of each of the following. 125% the full load current rating of the highest rated motor. 2. Sum of full load current ratings of all the other motors in the group. 3. 100% the non-continuous non-motor load. 4. 125% of the continuous non-motor load.
So for this situation, they're just saying that if you are going to supply multiple motors off the same circuit, it best be ready to handle all motors running at their full bore, right? Is that hard to digest there? Okay. So if you have two motors pulling 60 amps, you don't want it to have it on an 80 amp breaker or run it with 6-gauge wire. You know what I mean? It's got to be able to handle both motors on with their full current.
NEC definition, utilization equipment generally other than industrial that is normally built in standardized sizes or types and is installed or connected as a unit to perform one or more functions such as clothes washing, air conditioning, food mixing, deep frying, and so forth.
So that's what qualifies as an appliance. You want to take this next slide?
Appliance branch circuit over current protection. Marked with maximum size and protection device. Not marked, NEC 240.4 applies. Storage type water heaters. Branch circuits required to be 125% of load for NEC 422.13. Appliance grounding. Requirements are given in NEC Article 250.
But most appliances are going to have a nameplate on it that tells you how many amps they pull. And some, especially air conditioners nowadays, will tell you an average minimum and maximum service size. So when they say minimum 25, max 30, so you can run, 10 gauge, two number 10s. You can have a minimum size of the breaker being a double 25 or the maximum size of the breaker being a double 30. Could you put a double 50 on it and it'll work? Absolutely. But there now you have an extra 20 amps of trouble before that turns off. So that's why it's common that they give you a minimum and a maximum. I know on air compressors they do it all the time anymore. But anything that involves heat, anything that you think that can run for over 3 hours at a time, always throw that 125% on it. Baseboard heaters, you know what I mean? Even sometimes dryers, like big commercial dryers, those things can run and run. So if it has a heating element, it's usually a good idea to add 125%.
Appliance disconnecting means required to be provided for each appliance. Permanently connected appliances covered in NEC 422.31A and NEC 110.25. Disconnecting means must be inside of the appliance. NEC 430.109 lists the types of disconnecting means permitted. Disconnecting means ampere rating covered in NEC 430.110.
And take this last slide.
Disconnecting means for more than one motor covered in NEC 430.110C2. Appliances with integral unit switch covered in 422.34D. Cord and plug connected appliances covered in 422.33.
All right, so when it gets down to this, once again, just dealing with the motors and dealing with appliances, if it's hardwired, the disconnect has to be visible within line of sight of that unit. If it's plug-in, that's usually your disconnect. All right, so once again, the disconnect applies to hardwired situations only. Oh, everybody's favorite subject, grounding.
Grounding, NEC 250.4 and alpha 1 and 2, why equipment must be grounded. NEC 250 110, equipment fastened in place or connected by permanent wiring. NEC 250.112, equipment is fastened in place or connected by permanent wiring. NEC 250.114, equipment that is cord and plug connected.
But once again, if we go back to our grounding and bonding lesson, normally anything that's made by a manufacturer and is UL listed is going to have all the ground points, neutral points, hot points listed on it. So hooking these up isn't the hardest thing in the world if it's an appliance. If it pulls 30 amps of 240, then you're probably going to bring 2 10s for power, a 10 for neutral, and a 10 for ground. And there's going to be ports on that unit to properly ground it because it was made and it was UL listed. So hooking up appliances isn't too bad. It's normally pretty well spelled out for you. I'm not concerned with bakery. All right, let me do the summary.
Appliance maximum size and overcurrent protective device rating not to be exceeded. Appliance grounding requirements are given in NEC Article 250. Disconnecting means NEC Rule Number 1 must be in sight of the controller. NEC Rule Number 2 must be in sight of the motor location and driven machinery.
All right. Do you have any questions on what we covered here? I know this is very introductory. I know I was trying to keep it just surface level. I wasn't trying to dive too deep into like sizing up a motor and all that shit. But but this ties heavily to PLC. Here, let me grab a marker from the other room. Bear with me for 1 minute. You guys will also find out in, well, you're already finding out, I'm sure. In PLC, it's all about control. Your control work is what's hardest. That's enough already. Now, I imagine in PLC you have something like that going on, right? Something along those lines. You're doing the control side of it, right? Is anybody like curious as to how this translates to the real world motor control yet? Or are they explaining it adequately enough to you? But just know that everything you're doing in PLC, I know it's tough, I know it's a strife, I know it's a big complaint, I know it's computers, I know it's not working with your hands. I know it's basically everything you guys don't want to be doing. But it's really going to pay dividends to when you get to motor control, because in reality, you guys are just doing this in PLC. When in reality, this is just the control side of the circuit. You're going to have the low side, you're going to have the high side. The high side is going to come up and it's going to spin a 3-phase motor. Even in motor control, the hard or the easy thing is actually hooking up the motor. The motor only hooks up so many different ways. It takes you 10 minutes. It's super easy. The control work is the real involved process. Even hooking up your motors, sizing them accordingly, it's all equations, it's all pre-made. But for your control work is we need to figure out how your minds could work in the control sense. You guys, wiring up receptacle switches. In reality, this is just nothing more than switches. It's either open or it's closed. It's letting power pass or it's not. So when you're in PLC, think of everything just as a switch. It's on or off. It's letting power pass or it's not. That's a stop button right there. That's normally what? What position is that? What's its state? Normally open or normally closed?
Closed,
Why?
because it needs to be able to flow through, and then for the shut off, it needs to open up when we turn
Yes.
it off.
Right. So if I cut off your arm, can you keep on running for a while?
Yeah,
Probably for a little. Yeah, you die eventually, probably, right? But you got me for a good minute or two. You can run after me real pissed off. Why'd you jump my arm? But if I cut off your head, you'd stop right there, right? That's why we always put the stop first in normally closed. So if I hit it, it becomes what?
It becomes open.
Yeah, not normally open. Normally just means it's off position. And that's the reason why we want our start conversely to be normally open. So when we hit it, it becomes closed. And now there's latching and all that happy horse shit that we haven't even done yet, but good. Or is there any questions on motor control? Anything we covered today? Anything kind of bleeding over into PLC? Anything? You guys want to go home? No? Okay. All right, that concludes today's mission.